Hello, I'm Adam Taylor, and as we all know, trying to achieve timing closure is one of the big challenges that we face on our FPGAs. Now, depending upon how we write our code, that can have a significant impact on the decisions that the tool takes when it comes to mapping that to resources in the FPGA. The best way that we can do that is to read the user guides and the user manuals to make sure that we're writing our code in a manner that best reflects what we can get for the optimum solution in the target device. Over the next few minutes, let's take a look based around a DSP48 example in an AMD FPGA and see just how different results we can get from looking at simple things such as resets. Okay, so looking at a DSP48 example here, what we can see, we have the multiplier in the middle here that we want to leverage. We have the dual registers here, so we want to have two stages of registering before. We've got the dual A and D registers again, so we want two stages of registering before we put it through the multiplier. And then, of course, we've got the output. We've got the output registers which we want to use. Depending upon how we write our code, as you're going to see in a minute, will show whether our registers that we instantiate in our code and how we use the resets, whether it actually maps to these registers or not. Okay, as we've created a project which is just targeting any AMD 7 Series Ultrascale Plus or Versal family devices, we've created a simple bit of code here. This one's doing a synchronous reset on a multiplication between two numbers. As you can see before, we're providing the two delay stages. And the crucial part here is in the reset element. The reset element is occurring in the rising edge of the clock, making it a synchronous reset. And then if the reset's not active, we're running through and doing a multiplication and popping the data out. When we run this through and we do the synthesis, we can take a look at the implementation results. And the critical one here is we see that we're using one DSP. The 66 IO is just because we're working with all of the inputs and outputs. We're not too worried about that. And obviously one buff G as we would expect. If we were to take a look at the synthesized schematic, what we can see here in the middle, if we zoom in a little bit, is we can see the input buffers going straight into the DSP48, and that's because it's been able to pack the registers and use the registers in the DSP48 because we used a synchronous reset. Let's take a look now at the other case where we can't get the registers into that DSP48. Okay, so now we've created a project that uses a asynchronous reset. As you can see, the exact same code as before, the two 16-bit inputs, 32-bit output, doing the multiplier. Again, we've got the two stages of delay as required. Down in the code now, we've got the reset element is separate and outside of the clocked element, which gives us an asynchronous reset. If we run this through, what we can see is quite a significant difference. If we take a look at our implementation results, this time what we find is not only are we using one DSP, but we're also using 65 flip-flops and a number of lookup tables, because this is how we've defined the reset prevents the synthesis tool and the placing tool from being able to implement the registers that we've used in the B register, the D register, the P register, for example, in the DSP48, and means that actually these have to be implemented in the fabric. So if we look at the schematic, then in this instance, what we can see is that the delay registers are all implemented in the fabric outside of the DSP48, and similarly the DSP48 is then instantiated. What this means obviously is that we've got a lower performance because obviously there's more routing delay in between the registers and the DSP48, which impacts our performance. It also obviously impacts our utilization because we're using a lot more registers when we could be effectively using the ones within the DSP48. And that can also have some impacts on our power. So I guess the lesson from this little video is to really think about what you're going to do when you're writing your code and what you're mapping it to at the hardware level and where you intend it to go to. And that will help you get a much better result. If you want to learn more things like this, then obviously take a look at the Ultra Fast Design Guide or take a look at our website. Thank you very much.